Now name the ionic compound form from each of the following pairs of elements. Name. We're going to name them. Magnesium and nitrogen. So how do you name it? Magnesium and nitrogen. The first atom, which is your cation, you're going to keep it as magnesium. And with the nitrogen, what would the nitrogen become? Nitrogen is a non-metal. It would become nitride. So that's going to be magnesium nitride. And between cadmium and iodine, what would you say? Cadmium is the metal and iodine is the non-metal. So the cadmium has to go first. So it would be then cadmium iodide. Okay. And between strontium and fluorine. Strontium is the metal. You're going to keep it as the first element. And then the fluorine would be a second element. Fluorine will become fluoride. So strontium fluoride. And between sulfur and cesium, you figure out which one is the metal. Cesium is the metal and sulfur is the non-metal. So it would be cesium sulfide. Okay, that's how you name them. Magnesium nitride, cadmium iodide, strontium fluoride, cesium sulfide. And then it's asking the next question. Write empirical formula for each of the compounds named in sample problem 2.8. So you name the compounds first and now you want to write the formula. Let's see how we can write the formula. So if you look at your periodic table, you locate where the magnesium is, and magnesium is in group 2. Common ion it makes is +2. So magnesium +2. Nitrogen, you go to your periodic table. If you don't remember, you go to your periodic table and you find out nitrogen is here. Nitrogen makes N3-. So in a compound, nitrogen will make N3. So you're going to write it there. Go ahead and draw it. Once you put your charges, then what you're going to do to figure out the formula, you're going to do the crisscross. You take these 2 and put next to nitrogen, take 3 and put next to magnesium. That will make it Mg3N2. And that's going to be the formula for magnesium nitride. Okay. We do the same thing for cadmium iodide. So you go to your periodic table and figure out where is the cadmium and what's the common ion it makes. So cadmium is right there and it is given it's going to form +2. So cadmium +2, and you go to iodide and find out what's the common charge iodine makes. It's -1. So you're going to write it down. Cadmium going to make +2 charge, iodide going to make -1 charge. Once you figure out the charges, then you crisscross them. That will make it cadmium 1 I2. Normally we don't write when you have just 1. So you can basically remove that and then you can write CdI2. That's cadmium iodide. Okay. And then for the strontium fluoride, you refer to your periodic table. You find out where the strontium is right here in the group 2, strontium +2, and then the fluoride is here, F-1, strontium fluoride. So strontium is +2. I'm going to go ahead and write here. So strontium is +2, and then the fluoride F-1. And then to get the formula, you take these 2 and put right there, and then you take 1 and put right there. That will make it SR1. You don't normally put SRF2. That's strontium fluoride. And then the next one, cesium sulfide. Again, you go to your cesium. Cesium is in group 1. right there. It's going to make plus 1 charge, cesium. What's the other one? I forgot. Cesium and sulfur. Okay, cesium and sulfur. Cesium sulfide, and you go to sulfur. Sulfur is in group 6, so sulfur makes 2 minus charge. So you're going to write down these two, cesium plus 1 and sulfur minus 2. Cesium, you first write cesium because that's going to be your metal. Cesium makes plus 1 and sulfur makes plus 2 charge. And then you crisscross the number. To get the formula, there would be CS2S, cesium sulfide. So that's how you draw the formulas for the ionic compounds. Okay? Yeah, this is the answer. And these are some metals that form more than one monoatomic ion. Okay? More than one monoatomic ion. For example, chromium. Chromium can have two, chromium 2 plus, chromium 3 plus. If they are making more than one, when you are writing the name, you have to say chromium 2, chromium 3 to identify which is the charge of the ion. And their common name, this is chromous, this is chromic. Always the lower oxidation number would be ending with OUS. The higher number will end in ic. And cobalt can be cobalt 2, cobalt 3, cobaltous and cobaltic. And copper, copper plus 1 and plus 2, copper 1, copper 2, cuprous, cupric. Iron Fe2 plus Fe3 plus, iron 2, iron 3, ferrous, ferric. And lead Pb2 plus and 4 plus, lead 2, lead 4, plumbous and plumbic. And mercury can be 1 and 2, mercurous and mercuric. And tin could be plus 2 or plus 4, stannous, tannic. So if it involves an element, mainly in the transition elements, that has more than one charge, when you are writing the name, you have to represent which charge that you are referring. So you have to write the charge in parentheses like this, in Roman numerals. Okay? Okay, now with that in mind, give the systematic name for each formula or the formula for each name for the following compounds. Now we have tin 2 fluoride. We have to give the formula now. It's given tin 2, and tin has more than one oxidation state that we saw. Could be 2 or 4. In this case, it's 2. So, meaning we know that tin is oxidation number or the charge plus 2. And fluoride is in group 7, so F minus 1. To get the formula, you crisscross the number for the charge, and that will make it SnF2. Tin 2 fluoride is SnF2. Okay, and then we have chromium and I3, and you need to know how to write the name for this compound. How would you name it? Now chromium is not a main group element. It's a transition element, meaning chromium can have more than one oxidation state. You see, chromium can be either plus 2 or plus 3. So we need to figure out what is the chromium in CrI3. So let's see. So you are given CrI3. And if you don't know what is the charge, remember we can crisscross to get the formula, and similarly we can crisscross back to figure out what's the charge. And if you don't have anything, meaning that's 1, and you can go and put it right there. So the charge of the chromium is plus 3 and charge of the iodide is minus 1. So crisscrossing back. Always the first element is the metal, the next element is the non-metal. Metal is the positive ion, non-metal is the negative ion. Now this is So by doing this, you can find out what is the charge of the chromium. So when you write the name, then you have to write chromium, chromium, chromium 3. Chromium 3 iodide. Don't have space to write here, iodide. So the name going to be chromium 3 iodide. Chromium 3 iodide. You see here? Anion is I minus, 3I means that chromium is plus 3, Cri3 is chromium 3 iodide. That's how you're going to write it. And then the next one, ferric oxide. Now you refer here, it's given common name, ferric. When it says ferric, the charge of the ion is plus 3, ion 3, plus 3. So keep in mind, so we're going to write the ferric oxide. And then the oxide, if you refer to your periodic table, oxide is here in group 6, 2 minus. So how would you write ferric oxide formula? Ferric, so I'm going to write over here. Ferric is F3 plus, oxide O2 minus. Now you need to write the formula. You figure out the charge and then you crisscross the charges, and that will make it Fe2O3. So ferric oxide is going to be Fe2O3. Fe2O3 right there. Okay. I wrote in a wrong place, but I'm going to write it over here again. Fe, ferric is plus 3. Oxygen, oxide minus 2. So you crisscross to find the formula Fe2O3. Okay, ferric oxide. And then the other one, COS. Now what is CO? You're going to go to your periodic table and figure out where the cobalt is. Or you can look at the ions. Over here, cobalt. CO represent cobalt. COS is what we had. So CO2 plus or CO3 plus. Okay. There are two possibilities. It could be the 2 plus or 3 plus. And then you go to your sulfur. So where is sulfur in the periodic table? Right here. Sulfur normally makes -2. So our the name that we want to write is for the COS. Sulfur is 2 minus. So you go to your question. COS. Okay. So cobalt and S. So this is the formula. They are in 1:1 ratio. It doesn't mean cobalt is +1, sulfur is -1. Remember we saw sulfur is -2. So cobalt could be either +2 or +3. So sulfur is -2. So cobalt has to be +2. And when you write the formula, it would be CO2S2, but since it's an ionic compound, we can divide it by the common factor to have COS. Okay, and that's how cobalt sulfide formula came in. And then the name should be cobalt 2 sulfide, cobalt 2 sulfide, because cobalt is a transition element, can have either 2 or 3. So you want to specify in COS cobalt is 2, and then the cobalt 2 sulfide is the name. Okay, and these are some common polyatomic ions. Now so far we had seen common monoatomic ions. Now these are polyatomic ions. They stay together as a one unit, and this is ammonium ion +1 charge, and this is acetate, cyanide, hydroxide, hypochlorite, chloride, chlorate, nitrite, nitrate, permanganate, and all of these are common polyatomic ions, and hydronium is a +1. Most of them are anions, and this will tell us what's the charge of the ion. Carbonate -2, bicarbonate -1, and chromate -2, like that. Okay. Also, I have posted on Blackboard a periodic table and a handout at the very beginning of the lecture, in the lecture link. You can open it up, and there is a page, I believe it's page 6, that has more common polyatomic ions. So you can refer to that as well. I'm gonna conclude this session here, and then we can start the next one in another session.